Hello, Al. All right. So with me today, I have Al Lindsay. He's an engineer by trade, built and led the team that created Amazon Alexa Echo. And of course, Amazon Prime back in the day, 2008 to 2011. Al, welcome and tell us a little bit about yourself and what you've been up to.
Hey, thanks for having me, Finn. And yeah, just to sort of expand on a few of the things you mentioned there. Engineer by trade, studied computer science at the University of Waterloo in Canada. Worked in telecom for 10 or 12 years in the Canadian industry, and then joined Amazon in 2004. And worked roughly 15 years at Amazon, culminating in the last 8 years being dedicated to Alexa and that whole space.
Yeah, I mean that must have been an incredible journey of growth. I mean, there's very few companies that have accelerated at that rate to that volume.
Growth in every dimension you can imagine. I mean, for a while there, it was the fastest consumer electronic product growth, beating even iPhone in the number of units and devices built and sold, but also in terms of organizational growth, going from a team of literally zero to now over 15,000 people working on Alexa at Amazon, going from a small number of cloud-based hosts supporting all of those services to tens of thousands of nodes handling massive volumes in the cloud. So scaling services, scaling teams, scaling device manufacturing, shipping, customer bases. A lot of really interesting, fun lessons learned there.
So those 15,000, I mean, those weren't people delivering parcels. Those were people working on the Alexa project.
Yeah, on Alexa itself. So, a large team of scientists and engineers and product managers, but also, transcription, annotation, data experts, UX experts, across the board. It takes a village to ship a product, and large teams across all those domains. Just to give you an idea, I mean, even just the music aspects of Alexa alone require its own organization focused on making the best music experience they could possibly have in the music domain. And then you can just take that and expand it across all the various capabilities. And then there's an app that goes with it as well, the companion app. So there's a lot of moving parts had to come together to ship that product.
Yeah, incredible. And so when you were in the midst of all of this, where were the big challenges? And I mean, this was NLP back in, this was sort of 5-10 years ago, back where NLP didn't have what it has now. What were the big hurdles that you guys feel you overcame?
Yeah, the Stone Ages of NLP.
That was the phrase I was looking for. Yeah.
I think speech recognition was probably our first largest challenge, and specifically because we had elected to tackle the challenge of what I'd call ambient computing. The agent that's just there, you speak to the ambient air, you're not looking for the device, you're not picking up your phone as you would with Siri, pressing a button, holding it close to your face, but rather being able to call a command out to the room, hey, play music by Sting, and have it work. That far field speech recognition challenge was largely, talked about as an intractable problem because of the challenges of distance and signal to noise ratio. So there was a general belief that, you just can't get good enough with far field speech recognition to have a product like that. And so tackling that one head on was probably one of the largest challenges that we had to overcome to build the device. And we were the first team to deliver a product in the far field that worked as well as it did. You can layer on top of that the NLU challenges, because I think you noted it was sort of the early ages of NLP, what I call NLU, natural language understanding. There weren't a lot of great existence proofs of this multi-domain natural language understanding. Sure, Siri came out sometime after we had started this project. Siri came out in 2011. And sort of maybe the first instance of it. But I think even now we've come to learn that a lot of what Siri did in the early days, and what everyone has done, I think, to date, is a mix of rules and statistical methods, where the rules generally carry a lot of the core business logic. So, figuring out how to go from a cold start on an idea like Alexa to how can we have really advanced, sophisticated, highly functional natural language understanding algorithms that make the customer experience great for customers when they might be asking for any of dozens or now thousands of intents was an interesting, continues to be an interesting challenge for that team today, I'm sure.
Right. Because this is one of almost the best kept secrets in NLU or NLP, right? Is that a lot of these systems are not some secret algorithm that does the works, but are incredibly long, complex sets of rule-based systems that try and take into account everything that a human can possibly do.
Yeah, and I don't want to imply that that it's only a rules-based system. Obviously, rules play an important role in bootstrapping systems from a cold start perspective, so you can gather data, and then data starts to play a bigger and bigger role over time as you get more and more interactions with live customers. But I think a lot of smaller businesses, customers, and providers today really do have to rely on those rules to get their systems up and running in the absence of the right kind of data that's matched and collected in their production environment. Yeah,
and that may be sort of takes me on to the question of if you were going to comment on how have you seen the field evolve? Like in the last sort of 5 years, I mean, I think around sort of 2016 there was a real rush of startups and money that went into this problem of human speech and recognition. And you've got a wider arc of seeing how the field has evolved, both from the academic and the very applied levels. How would you sort of describe that arc, and what are the notable developments?
I mean, what the first one to look at, I think, would be the ASR, the automatic speech recognition space. That technology has been around for a long time, since the 60s. And really didn't make a lot of massive advancements since the early deployments in the 90s of IVR systems. And then I think the greatest advances that took place, and one of the ones that we helped push, the science team did, is around applying deep neural networks to replace the sort of traditional hidden Markov model approaches that were being used in ASR. And we saw great gains, but a number of other things came to play. I think moving to the cloud and the immense amount of compute power in the cloud, leveraging GPUs for massive data sets at scale, and to be able to do that at an affordable price point was definitely a sea change in what you could do in the AI space more broadly too. I think leveraging massive amounts of compute power in the cloud, where your data and compute are very close together. And leveraging that with a lot of these more academic advances and scientific advances, things like DNNs and CNNs, and there really are a thousand smaller things that all came together rather than any one big sort of aha breakthrough. But I think the track of ASR really accelerated through the tens, if you will, the 2010s. And we see that everywhere. Everybody's ASR technology is far more accurate, and we all find it a lot more tenable as something that we're willing to interact with now than it was, say, in the aughts. So that's the one area. I think in Alexa land, obviously voice technology, the spoken voice, the text to speech voice is another area where we saw massive improvements, again applying deep neural networks and large data, and moving away from the sort of classic unit selection approaches where you record all the little snippets and stitch them together and try and smooth out the transitions, to more of a machine learned big data approach to making voices. And now I think it's just commonplace. You expect a TTS voice to sound almost human. And you wouldn't tolerate the voice of Stephen Hawking being generated from some of the old techniques. It's just it's moves so fast. So, the ability to understand the words that are being said from ASR and to be able to speak to human in a very natural way have made great advances. I think the NLU side of the house has been a little harder. I think we're all seeing the companies who are doing generalized AI, sort of if you look at your Siri, your Samsung Bixby, your Google, and your Alexas. because the breadth of things that they attempt to understand is so wide, the confusability goes up dramatically,
Sure.
and it's just really hard to have that highly accurate understanding of what the customer actually wants to do. I'll give you an example. The word play is immensely overloaded. Do you want to play, a video on your Fire TV, music, a YouTube, a song, an audiobook? So just relying on, an action word like play to give you a solid intent isn't nearly sufficient enough. Whereas I think in the beginning, for some of the simpler or narrower agents, you can get by on those sorts of
Right.
less ambiguous
Right.
examples. So I feel that a lot of headway's been made in the NLU space, but I know the real challenge is getting to more of a conversational understanding of natural language. It's more like as a human operates, and brings to bear all of the context and maybe visual signals and body language reading and history of conversations, and even sort of contextual history of the world and pop culture that comes to bear when we have conversations, and
Sure.
you're able to infer from a small number of words.
Sure. Yeah, absolutely. And I sometimes like to sort of separate these problems into maybe the engineering issues, and then the more fundamental sort of mathematical ones. And
right.
So certainly, you mentioned the ASR being around since the 60s, and it's not until we get the latency down that the system starts to work. So all of these things coming together to be a speaking computer has this whole question of latency. Once the problem has been mathematically solved, but then there are these gnarly questions of exactly what are the rules or what are the algorithms behind which we do this. Could you sort of put certain parts of that into different camps? What are the engineering ones with a bit more power and speed we can crack, and where's the big unknown?
I will say that sort of both philosophically and practically, it's hard to separate the science from the engineering, and the more you can combine those thinkings together, the more successful you'll be in the space. Because if you do your algorithms and your math in sort of an experimental bubble and in non-production sort of coding techniques, it's very hard to then take that and turn it into a real runtime system that's fast, as you said, low latency. So I find there's always a delicate balance of making sure that you're combining your engineering thinking with you're trading one off for the other. Almost always you're trading off maybe the cost of the underlying infrastructure, what your latency is and what your accuracy is, and they're intimately tied. You can always make it faster by being less accurate. You can always be more accurate by being slower. And you can take forever if you want to explore every possible outcome in a brute force way and come back days later with an answer. And so there really is, you have to look at these in tandem, but absolutely the latency for me from an engineering challenge perspective was one of the most important things we focused on from the very beginning with Alexa, sort of understanding every component of it and trying to crush it down into the smallest window that you possibly can. And I think a little bit of that muscle came from being an e-commerce company where, right. A slow web page meant lost sales. Right. And that notion of, if you don't respond within a second, you've lost your customer. And so we took a similarly aggressive approach with Alexa and trying to be super low latency right out of the gate.
Yeah. Yeah. Interesting. And so you moved on from Alexa now, and you've got some other projects going. Could you tell us a little bit about what the latest game is?
Sure. I've sort of been enjoying a return to small companies and startups, which is sort of where my career began in the telecom space back in the 90s with a series of startups. So I've taken on advisory roles with companies that are working in the AI space, particularly with speech, and also advising some large multinational companies in that space as well on their efforts related to speech and NLU and how they apply to their businesses. Seems a lot of interest in this space right now. Everybody's trying to do it, but it's not yet mature to the point where, if you want to go out and write an iOS app, you can find all the resources you need, well-trodden ground, and figure out how to do it and hire the right people and train them and get it done. There's still a lot of, it's fairly nascent space. Everybody wants to get into the space and leverage the technology in their products, but it's hard for them to find solutions that don't require them to go out and staff scientists or
Right.
highly specialized people who just aren't. Yeah,
we're not at the stage where we can copy the code from GitLab and build a startup quickly, right?
I think the idea of democratizing speech as an interface in technology still has some ways to go.
Yeah. And is it coming soon? Is there a?
I think, as is always the case with all of these things, it just takes time. It's coming, and it's massive compared to what it was. I can tell you when we were getting started with Alexa, I mean, even finding someone who had an expertise in voice user interface design, there was really only one company you could go and hire those people from, and that is no longer independent as of a couple of weeks ago.
Yeah.
If you look around now, you'll find all kinds of design firms and engineering shops and platforms and startups that are offering tools and training and expertise and solutions in this space that didn't exist even 5 years ago. It's definitely growing quickly, but it has a long way to go.
Okay. So tell me a little bit about Elerian and what these guys are doing.
I think what's drawn me to Elerian that I find interesting is the idea that they're taking a voice forward approach. So they're operating in the call center space and building solutions for call centers, but they've approached it from how do we solve for the virtual agent's speech problems first, and in particular, how do we build a really high quality natural language understanding component that's able to make sense of what's going on in the conversation with the end consumer, and allows their partners to provide a more human-like experience without necessarily having to staff a massive human workforce to do it.
Right.
So I really was drawn to the solve the hard problems first. That's close to my heart. Go after the. I mean, it'd be easier to go and build another call center in a box solution that integrates with all of the the existing products that are out there. There's plenty of people who have done that, and that's straight engineering problem. It's much harder to go after the novel speech challenges first, nail those, and then use that to drive the more straightforward engineering challenges that come with a call center. So
right. Because they've got a couple of tricks up their sleeve, right? So they've got this compression thing they can do, and then they've strung together this stack of they can understand the voice. They've put that together with the sort of some rules, but there's an information model which decides what's going on and the flow of it. Does that can you elaborate at all on that? Or
yeah, I think again, another thing that struck me was just sort of the maturity and the breadth of considerations that went into that NLU platform. So, things like context and caring for context from turn to turn, bringing to bear the customer's specific data knowledge about their customers, whether it's incorporating their email addresses, which would not be an vocabulary thing for an off-the-shelf ASR or entity recognition solution. Just sort of the ability to tailor the models more.
Because I mean I can still phone up my bank and I say when it says when's your birthday I say 1st of April 1978, and the thing that the thing says please say it again, and it doesn't get it. I mean you think this is a solution deployed on a fairly large multinationals behest, and it's still not picking up these basic things, right? Because it's this big long string of rules. So it's really refreshing to see a company come to the space like Elerian that starts to address this.
Yes, and there are just so few functional NLU solutions today, as you note, that are able to do more complex utterances like that. Right.
Which brings us on to the big players. I mean, it's not as if the Googles and the Amazons and the Watsons of this world are ignoring the area. What are they up to, and where's the difference? And is there space for a startup like Elerian or other players, or are they going to get squashed? What's happening there?
I mean, it's like I said earlier, I think it's such a nascent and rapidly emerging space. There's room for lots of players. And if you take a look, you mentioned some of the big guys, your Googles and your Samsungs or your Apples and your Amazons. I see a couple of different things emerging from the large companies. One is platforms, AI platforms, tools to let speech scientists or, just data modelers and AI scientists in general or engineers take data and turn it into models and deploy them and run them in the cloud and be able to recognize whether it's, video or images or voice or, build NLU solutions. So you have a rich set of tools that are emerging from a lot of the large players. Those tools have some challenges in that you need a certain level of expertise in your engineering and your science staff to truly leverage them. And then in a lot of cases, you come up against you can take it so far, but then now when you want to supplement that language model with your own language model, or constrain it, or maybe tweak the algorithms to more favor your use cases deep inside the ASR or the NLU engine. You just can't do it. You just can't open up. You open up so many of the interior boxes, and then you hit a wall.
Yeah.
I think the other thing I see them doing is, I mean, you see the general agents like we built with Alexa, who are doing a massive breadth of things and really approaching sort of the largest breadth of capabilities that we see in virtual agents, which is interesting, but completely different set of challenges than what I think Elerian is facing in going after initially things like call centers where the problem space is much more constrained. And you can get
they don't want to have general conversation. They want to have a conversation which is as tightly controlled as possible, because you don't want agents going off script, right?
Well, you want to get to the quick resolution for the customer that solves their problem and provide the best customer experience without frustrating them with errors and inaccuracies.
Yeah, and then the other part of that is, I suppose, is regionality. As far as I understand, they're working with Elerian are working with a South African call center, and that has unique aspects that you don't get out of the box, because you've got all these very specific regional accents, and is that's something that we take for granted if we're in London or the US. We take it for granted that the big tech players are going to deliver solutions for us, right? As soon as you step outside that, there's issues specifically with NLP NLU, because these algorithms need to be trained on the right data.
Yeah, I think that's true broadly of all AI and speech recognition NLU. You need to train with the right data that's spoken by with the local dialect by local people, humans, in the environment where they would actually be speaking it. So I mean, the best. There's no real substitute for data collected in the actual use case scenario from real customers doing real activities to train your models. It's just the best data to get the highest accuracy.
Yeah. And so for NLP, NLU, I mean, do you think that, are call centers where the sort of NLP, NLU breakthroughs of the future going to be born, or is that the market driving force, or I mean, there's probably a few, right? So
I think what we're seeing is this technology, speech, spoken language understanding, and sort of artificial voices like text-to-speech being applied to almost every facet of business. So I think call centers are one important element of it. I think we're seeing it in almost all areas of business. So I think the advances are going to come sort of across the board and be pushed from a lot of different marketplaces, which is one of the interesting things about taking a voice first approach if you're Elerian, and then applying that to a vertical like the call center vertical, is now all of the things that you learn and feedback into your systems can be leveraged to then apply that same tech to other business cases.
Right. Yeah. And then, again, it's this technology that's been wished for, and people have had various punts at doing this, because it's such a big thing, right? It's such a natural thing to have a computer that can talk, or a system that can talk back to you. It's been written into science fiction from the year dot,
Sure.
and yet again, time and time again, and advances happened. We haven't had it. We haven't got that talking computer. Another advance has happened. We still haven't got there. Is there a tipping point where this stuff all gels and suddenly we leave our desktops behind and we just wander around the street talking?
Well, I do think that voice as a user interface is amazing and natural. You don't have to be trained on how to use it. It's accessible to everyone, including people who grew up without technology, seniors. But I don't think it's the only interface for all scenarios. So, you mentioned walking around on the street. Imagine you're sitting on an airplane, getting ready to take off, responding to your email.
Yeah.
I think there's an example where your text-based chat might actually be a better interface just from social norm.
Yeah.
But voice is definitely that natural interface that allows you to just leverage what you've been learning since you were an infant, without having to think about, what does that box mean? Does that chevron represent there's more information if I touch it? Having to be trained to use a totally different user interface, even though the phone with its touch interface felt so natural, you just see it and you touch it, you still have to be able to understand the hints and the cues and the user interface design with voice. The holy grail would be that it's like talking to another human, and if you even if you have to fumble your way around a bit, you're able to figure out how to get what by asking or rephrasing or approaching it in a verbal way.
Right. All the sort of auxiliary words we use to say what, please say that again, or break, interrupting someone's sentence, that kind of stuff.
And I think there's also visual cues too. So I think vision science is going to play a big role as this moves forward as well. Because if you imagine you're at a cocktail party, pre-COVID, I guess, and you're talking to someone, but it's really loud, and your ability to focus, you've got all these different sounds, and if you closed your eyes and tried to carry on that conversation, you probably couldn't. So you're focused on that person's face. You're able to pick up visual cues. You might miss words or phrases, but you're able to infer based on the context of what you've been saying and where you are and how you know each other.
I had this Swedish roommate who was partially deaf, and her subjective experience when she saw someone talking was that the volume went up. And if you put a book in front of someone's mouth, she still partially heard them, but the volume was quieter. I thought it was fascinating.
Well, I think a lot of those human experiences for understanding language will come to bear in the technology world. So the ability to process video and get those subtle gestures, certainly things like context and history and current affairs, zeitgeist, things that are going on in the world today, what happened, you might be referring to something that was in the news this morning or that happened, halfway around the world and was a local event. So those types of things are already, I think, being utilized in a lot of the more general agents from the large. I think that area of advancement will be an interesting way in which we get to a more conversational technology that we have today.
I mean, imagine with something like Alexa, where you have to have a sort of a live knowledge of, all of popular culture, to play the right track when someone says something. I mean, how did you guys approach that question?
Yeah, there's having people and teams focused on ingesting the data. That, like, we literally have a zeitgeist team, a team that's focused on how do we figure out what are the most important significant events that are going on in the world right now and incorporate them into what we know so we can use it as context. I think like a goal is scored in the World Cup, and everybody just instantly knows. And we need to know that too, because it could then be part of, question coming into our question answer engine. So, being focused on where there are obviously thousands of sources for that data that you need to ingest from, and it takes time to build those out. But we put a lot of effort into our knowledge, getting live data as well as all the historical factual data.
Right. That's interesting. And I guess you have that distribution of what people ask for as well. And if the World Cup goal has a particular anthem, then 90% of the time when a certain sound is close, it's going to be this anthem that's played.
You have that. The interesting thing is the long tail. You never fully traverse it. There's
Right.
always something new that comes up, and it's looking at the long tail of missed utterances, missed questions that you couldn't answer, and figuring out how to solve for them that keeps you busy and keeps you up at night.
Right. Right. Yeah. So I heard an interesting stat recently, which was that that there's been this tipping point where in India, over 50% of Google searches are now done by voice, and it struck me that, again, maybe there's this legacy, because we're used to using Internet Explorer, we're used to well, whatever browser you use, right? Delete that from the video, right? Yeah. But that this generation of kids in India that have grown up with phones, but without sort of the desktops, have started to adopt voice in a way that perhaps we haven't, and that maybe this revolution or transition from desktop or from visual to sound is going to start maybe in the developing countries.
Maybe. I think, like as you noted, there are some technological and cultural elements that maybe drove that. The fact that everybody is operating on a mobile, and that it is actually easier to use your voice on a mobile to enter a string of words into a search box than it is to type it out. Right. So that definitely catapults it. I don't find a lot of people talking to their laptops.
Right.
It's a little more common to find people talking to their phones.
Right.
But I also think the more than 100 million endpoints out there that have Alexa, and then I think you got billions of Android endpoints and Apple endpoints, and so these the agents are available wherever you are now. You always have access to a voice agent wherever you are, and I think I'm sure that it continues to grow. I don't have access to that data anymore, but sure that the number of people using it and the number of times per day they use it continues to grow.
Right. Right. And of course, it's spread across these different categories. So I think we touched on earlier voice and chat, and the sort of differences between them. They both require NLU, but one has this sort of extra part sandwiched on the end to transmit the sound, turn the sound into words.
I would expect that the majority of those utterances and interactions are also command and control today. So,
okay,
whether it's a music or an in-car, send a text, read a message, smart home interaction, turn on the lights, make sure I close the garage door. I don't think there's a lot of conversation going on with agents, whether it's via or an Alexa device or other end devices. And I think that's really where the future development will take us.
And I guess that's partly what makes the contact center space really interesting, because that's
far more conversation.
Yeah. That's there's a whole range of things that people are discussing in there.
Yeah, it's a compound goal. There are multiple things that both the virtual agent and the human are trying to accomplish in that conversation.
Right.
And infinite things they might get from where they start to the end of that set of goals.
Yeah. And then the drivers for the contact centers to adopt this technology are, I suppose, pretty self-evident. There's one is the cost of being able to automate some of this stuff, and then two, but it's not just cost. It's they're aiming really for customer experience, right. And I guess there's ways for a conversational agent, an automated conversational agent, to not just reach the human level, but potentially surpass it.
Well, I think one of the things is that in the call center space, the workforce turnover is much higher than in other industries. So, I'm not sure, I don't have handy the stats, but if it's 10 or 20 or 30% of your workforce is still fresh, being trained, fresh off training, inexperienced. So the possibility for errors is higher. Whereas, with your virtual agent, you always have the expert, and probably, it would be your top expert out of all of your human agents in terms of what they know or what they can know. So always being able to reach an expert, I think is going to improve the customer experience on its own.
Right. Right.
Yes.
And that handoff problem where you make sure you get to the right person, I mean, that you sort of almost solve that out of the box, right? With an automated system.
And you're not waiting to reach that person.
You're not pressing 2 or 4 or whatever. You're just saying, I want help with this, and boom, you're there.
Right. Yep.
Yeah. I think that's it's a noble goal for any for any company. If we can get that waiting time down, then I think we've diminished the frustration in the world, right? Yeah. So what does the competitive landscape look like for this? I think again we talked about it a little bit before, but for a company like Elerian, where are the threats and what's the landscape?
It's interesting. I think there's there's lots of space. So I don't think that there's existential threats around for companies that have developed novel spoken language understanding solutions. I think it's an interesting market space where, as I said before, everybody's trying to gain the expertise. And what we're seeing is a lot of the big companies with deep pockets are bringing it in-house. So if a competitor starts to emerge that looks highly capable, we're seeing a lot of them get snatched up by large companies that want that expertise in-house rather than to leverage.
Because you just can't find the talent.
So what it results in is this constantly changing landscape of who the players are. There are some established players, obviously, that have been around for a number of years and likely won't go away because I think they have really viable large growth opportunities and plans if they stay independent. But there just aren't that many. So and again, when a bright one does pop up, it's I'm seeing them get snatched up a lot of the time. So it is hard to find companies in this space with this expertise. The second part of it is really the available talent with expertise in this space. I think a lot of people are rushing into this field, but the folks that really have the expertise are those who already have their 9-year PhD plus many years after that. And it's really hard to accelerate that just because there's a higher demand. So it is, Elerians lucky in that they have some of this talent on their bench, which goes a long way. I think it's hard to just start a company and find the talent you need to really have that deep expertise in big data, AI, ASR, NLU. There's a limited bench of people in the world with the expertise today. Right.
Yeah. Interesting. And does that talent get poached by the big players or does Elerian have sort of people knocking on the door going, please come and work for us?
I mean, I guess in that regard, it looks like the rest of Silicon Valley in that your engineers.
Right.
Too, so
keep your engineers happy.
It's highly competitive, just as it is in the engineering space. You should take care of your people.
Right. Okay, so I've got just a couple last questions, and it's they're sort of the big ones, which are always fun to ask at the end, potentially after we've had a few glasses of whiskey. First one is are we going to see this transformation happening soon? And how ubiquitous is it going to be? It's potentially a real revolution, right?
Yeah, I think massive investments are being made to push those advancements forwards and try to find those breakthroughs, technologies, algorithms, approaches, whatever it is, engineering strategies. I've obviously in working closely with folks on those challenges at Alexa, I mean, you really have a lot of really smart people focused on solving these problems. Yes, we're going to see advances. Where it's going to come from is probably all over, since there's so many different organizations that are focused on it with so much talent. I'm a little cautious that you'll see massive changes. I think often People expect that these things move in massive leaps and bounds, and that kind of like the whole time travel, slip in the bathtub, bang your head, and have a vision for the flux capacitor, thus making time travel possible.
Right.
It usually doesn't work that way. It's more perspiration, and there's a lot of invention going on. But you might try 300 different smaller or medium inventions, and 10 of them accrete towards your goal. And once in a while, you get one that moves the needle 20%, but it's not one big thing that's going to change it. It's all of this effort and aggregate, I think, that will result in a more incremental improvement over time. So there is a tipping point where those increments reach a certain aggregation that starts to create a tipping point in the consumer's mind where, it feels more natural and conversational, and they're more open to talking to their technology like they would a human. Right. And I'd love to see that in the next 3 to 5 years. I think a lot have to come together for that to happen, and I don't know what that is, or I'd be building it.
and is that thing AGI? I mean, is there? I guess that's a philosophical question, right? Is a computer that can talk and speak like a human the same thing as an intelligent being? Is that?
So the stuff that is made of the singularity, the whatever you want to call it, there's so many that Hollywood's latched onto over the last 5 years. And I think a lot of people are worried about the advance of AI. And
do we see it being born in a call center which handles your bank details?
I'm skeptical that we'll see it in our lifetime at the level that really causes people to pause and be concerned about AI, really being an existential threat, as you see in the movies. But rather, what I see is the advances in technology getting to the point where it really is quite conversational and useful, in a utilitarian way, or even in an emotional support way, or for sort of medical or mental health purposes. And so many great applications of talking to a computer that feels just like talking to a human, that don't involve arriving at the singularity and us being turned into copper tops, to steal a quote from the Matrix. Yeah.
Brilliant. Well, I think that's us coming up to our 5 o'clock. Al, it's been a pleasure, and I hope we get a chance to talk again soon.
Great. Thank you.
Thank you.